Hi, welcome to this session on modernizing intelligent apps and agents with .NET that scale as you grow. My name's Westgarth, and I'm here with Gaurav Seth, and we're product managers on Azure App Service, and we're delighted to be able to take you through some new capabilities inside Azure App Service that are going to seriously accelerate your journey to the cloud and your exploration with AI. Let's have a look at what we're going to cover today and what's the agenda for the session and key topics that we're going to cover with you. So when we talk about modernization of applications, there are a variety of challenges that organizations face. And we're going to get into those today and have a look at all of the different things that can cause problems while modernizing existing applications or scaling new projects. We're going to go and review a feature that we launched back at Ignite in November called Managed Instance on Azure App Service. Managed Instance on Azure App Service helps to address a number of those challenges and help to improve and speed up cloud migration without massive redevelopment of applications. At this build event, we're introducing a new capability inside Azure App Service called built-in MCP. We're going to dive into that and look at how it can help you to expose APIs as AI consumable tools, enhance that integration and automation capabilities, and you can use this new tool with both existing and brand new development. We'll take a look at how the GitHub Copilot app modernization tooling can help to identify areas with which you can make code changes or run assessments of existing applications to see any potential problems that you might run into during a migration project, but also use the power of GitHub Copilot to make those changes to your applications across multiple languages. And then we'll switch to my colleague for a detailed demonstration of everything that we've seen today. And then we'll wrap up with a summary and some key resources for you to go away and take into your next modernization project. Understanding modernization challenges. So through months and years of research and experience of working with customers that are looking to migrate and modernize a huge raft of different types of applications, we've identified some key application challenges that customers face. So legacy system dependencies often comes up in terms of maybe there's a heavy reliance on specific operating systems or capabilities within that operating system. So that could be key features, say in a Windows server, such as MSMQ client or maybe SMTP, or some APIs inside Windows, so GDI, drawing libraries, those kind of things. And additional from third parties. So you might have reporting libraries or control sets or things that were developed in-house that are key components inside your application. These often prevent challenges for customers looking to migrate their applications and scale. Often, especially with platform as a service offerings such as App Service, traditionally, we don't allow you to install third-party components or self-built components through MSIs and EXEs. We're going to look at how we've addressed that challenge. Stateful versus stateless design. So if your applications are very, very stateful, so you rely heavily on session management, that prevents massive scale because often your stateful session is managed inside memory as opposed into an external provider like a database or table storage, or maybe it's even a Redis cache. Where stateless architectures help with scalability and flexibility out of the box. So for some, you may have addressed these problems on premises where you've gone from individual server to more, or maybe it's now you're identifying that during a cloud adoption program that you need to tackle these problems. Configuration and secret management. So throughout industry and throughout different enterprises and companies, a variety of different scattered configuration management services are used, and the secrets are shared and managed through non-centralized tooling, but it's all unique to your individual flow. How do you handle centralized governance and secure management? How can Azure help you with this? Migration timelines. Often once an assessment's been done, companies are faced with lots and lots of different tasks that they need to be able to do to achieve their migration and to modernize. And often it's a case of this simple modernization on the face of it takes multiple months. How can we shorten that? And how can we increase the benefit of modernization projects to increase return on your investment? Managed instance on Azure App Service. So as I mentioned earlier, back in November at Ignite, we introduced managed instance on Azure App Service, and this is an offering that we have in public preview today. And the goal of managed instance on Azure App Service is to accelerate the move to platform as a service. So give you extreme flexibility, but high scale. You can preserve your Windows dependencies and bring them along with you, your third-party dependencies, or maybe it's dependencies that you have inside the Windows Server OS. You can unlock scale by being able to be on top of the platform as a service, so we can go from, say, 1 instance out to 30 instances quickly with a few clicks or a template deployment or a CLI command, rather than thinking I've got to go and rack up multiple servers, build them, build VMs, build physical tin. You can now do it at a click of a button. Security. Everything that's built inside managed instance is built with security in mind, be that from using managed identity to talk out to other services such as SQL for your database backends, or out to Key Vault for your secrets management and certificate management. And then on top of that, you can add functionality from Azure AI. And we're going to go into that into detail, so you can immediately take your legacy applications and add value immediately through agents and MCP. You deploy on top of our latest SKU, Premium V4, which is our most performance SKU in our fleet and has some really attractive pricing, specifically for Windows customers. The foundation for cloud adoption that we've built with inside managed instance on Azure App Service is to have this goal of minimal code changes. To be honest, we're aiming for 0 code changes as well. So we see that through managed instance being able to bring those dependencies, you can use a configuration script to bring those dependencies with you, install server roles or features, or make changes that you need to in order to bring your applications with you. In addition, with inside managed instance, we have the ability for you to be able to read and write to the registry and store those key values with inside Key Vault, so therefore managing secure secret chain all the way through. You can mount storage volumes with drive letters. So often on premises, it's something common to actually have a mapped drive using a drive letter as opposed to just a UNC file path. So therefore, you can preserve existing dependencies and configurations with existing applications without making any code change whatsoever. This is really valuable when you don't actually have access to the source code. Or maybe it's a third-party application that you bought in and you just cannot make changes to it. But it's absolutely critical to your business. And whether you're going through a data center shutdown or something similar and you need to move these applications to the cloud, you can now take this pathway. You get cloud-native benefits out of the box. So as we talked about in the overview, you'll gain from scalability of being able to go from 1 to n number of instances immediately, both in terms of horizontal scaling, but you can also go vertical scaling. So you can start off on a low-powered instance of maybe a single core and low RAM, up to some really powerful machines. So say 32 cores and 256 gig of memory. So depending on your application needs and your scalability needs, it's available to you at the click of a button, as opposed to long procurement processes. As we discussed, we built in high security all the way through. So we require you to use managed identities throughout. And then you can use those to connect to other Azure services to improve your security posture from day one. And you get the high availability that you get from a platform as a service offering by being able to use multiple instances, but also take advantage of things like availability zones to have your application spread into areas to enable that resiliency. Managed instance also offers operational offloading. So App Service is a platform as a service offering, and as a result, we take care of infrastructure maintenance, patching, scaling, freeing development teams to focus on value, and equally your operations teams, because the total cost there of operations teams having to patch all of these instances are gone. We take care of that for you. As a result, there's also a pathway for you to do incremental modernization. So we accept for some customers, managed instance might be a destination point. The application just needs to be migrated to the cloud. You prefer to go to a platform as a service. And after that, you're quite happy. You've made some small changes and that's the destination for your application. However, now you're inside the app service stable, if you like. You can then take that application and identify key areas where you want to do some incremental improvements. Maybe you want to rewrite some core component in a newer language like .NET Core or something else. You can take that piecemeal approach and do that. And you can reduce that risk and time to value for enterprises, as opposed to sitting and thinking, I've got to rewrite the whole thing before I can go to cloud. Now you can decide, no, I can do that on an incremental basis. So throughout, the data management is backed by Key Vault. So therefore, all of your secrets, your credentials, your configuration settings are backed with Key Vault and integrated with managed identity. Huge amounts of compatibility with storage. As I mentioned, you can do your drive letter mapping, but you can map onto Azure files, local temporary storage, or maybe even a UNC file share with inside your VNet. So therefore, still maintaining that application compatibility. Custom dependency installations. So you use an install script to enable inclusion of custom dependencies to support your legacy components. So that can be things from third parties. That could be something that you need to install directly out of the OS that is just not installed by standard. And for the first time ever, with inside Azure App Service, we actually allow you now to remote desktop directly to your instances using Azure Bastion. Security all the way through. We're using secure protocol, but also we're giving you the full access to those instances directly so that you can use tools you're familiar with. So if you're familiar with Event Viewer, you want to be able to use Registry Viewer, or you want to use, say, IIS Manager, you can now use these tools for troubleshooting and investigation. So to remove that friction when coming from having full control on premises to now having reduced control in PaaS. All changes and investigation that you make during those sessions is temporary. So i.e. they have to then be backed up by changes to your installation script if you're doing dependency changes or tweaks. And then you can have those persist. And the reason for that is because when we do maintenance or we replace instances on your behalf, then we need to reapply those customizations that you've made. And as a result as well, because you're on a platform as a service, as I've mentioned many times before, you get dynamic scaling and maintenance. So you can configure the platform to scale depending on the application that you need, or you can scale manually or on a time basis. Equally, the maintenance is taken care of by us, the platform team. You now don't need to worry about operational system updates or maintenance. We take care of that. And now I want to come to a new feature that we're launching at Build this year, built-in MCP. So with this new feature that we have within Azure App Service, we have the ability to add artificial intelligence value straight away with your applications. So built-in MCP enables your APIs to function as AI tools. So therefore you can immediately take advantage of those through agents and existing APIs. You surface your API and we detect that and we discover it with inside your application. And then we're able to expose MCP tooling for you to be able to incorporate and use with inside your applications. It's all secured via managed identity, OAuth and RBAC, so that we maintain auditable API interactions, and it's language agnostic. Built-in MCP supports multiple programming languages, so .NET, Java, Node.js, and Python, enabling broad applicability throughout. Here we have an architecture that Gaurav, my colleague, will show during the demo coming up, of where we've taken an application that is running on managed instance on Azure App Service, and it's a .NET framework application, and it's an inventory web API. So it's already exposed in an API, and then using Azure App Service built-in MCP, we're able to expose that so that then you can make use of those MCP tools elsewhere in your development frame. One key thing to stress here, this is a .NET framework application that you've built years ago, but you know that there's capabilities within inside that web API that you now want to expose to more modern development frameworks. Agentic application patterns. So with inside Azure App Service, we can host your agent-based modular design. So agentic applications use specialized agents responsible for distinct domains. So maybe you have an agent for your sales management, maybe you have a product agent, maybe you have a shipping agent, and they expose different functionality directly for different domains, therefore more modular and task-focused. With agentic application design, we often see orchestrator coordination happening between those various agents, so that when requests come into that orchestrator, it is able to determine which is the most efficient execution sequence and which agents need to be involved throughout those interactions. By having them modular and having them split into individual task-focused agents, it offers much more granular scalability. That means that as the user demands evolve, then your scaling can flex to those needs. We're also going to show, as we've mentioned in the previous slide, the fact that agentic design doesn't just require brand new greenfield projects with the brand new languages, with the latest versions. You can integrate directly with both existing legacy systems and brand new greenfield systems. Finally, we bring this together with GitHub Copilot app modernization tooling. So the GitHub app modernization tooling allows you to review your code through AI-assisted code modernization. Copilot's able to analyze code bases, both legacy and more up-to-date, and generates refactored code aligned with modern architecture practices. So it can identify where it can make improvements to your code to reduce problems when you move to the cloud, but also to align with new paradigms and improvements that exist inside the technologies that evolved over years. It means that using GitHub Copilot, you can have extremely fast greenfield development. So now with the correct prompts and with the correct scaffolding, we can generate new APIs, tests, deployment scripts, spin up prototypes very quickly and turn those more into new applications very, very quickly. The GitHub app modernization tooling supports multiple programming languages, including .NET and Java, making it versatile across a huge raft of development projects often encountered inside enterprise environments. With the GitHub Copilot app modernization tooling directly built inside Visual Studio now, we directly integrates with platforms like ours, like Azure App Service. So it enables you to do the modernization assessments to identify problems or areas for improvement before moving to Azure App Service. So therefore enabling much faster cycles and much better experience and collaboration across your developers without having to try piecemeal for doing those migrations. And you'll see in Gaurav's demo, we do a app modernization assessment of an existing application to identify any potential challenges of migrating that application to Azure Apps, managed instance on Azure App Service, but also you can use that tooling to look at other types of applications inside App Service. So maybe you have a Node.js application that you need to move to App Service Linux. The same tooling can help you inside that scenario. Now I'm going to hand off to Gaurav to give us a full demo and walkthrough of a lot of the different concepts that we've talked about today and see how it all fits together in order to help to modernize your applications and deal with challenges of scale, but also of dealing with modernizing the challenges of modernizing applications.
Thanks, Andrew. So, hello, everyone. My name is Gaurav Seth. I'm a product manager on Azure App Service team, and I'm going to demo all the concepts that Andrew has already covered as part of his presentation. So I'm actually going to start with the GitHub Copilot app modernization tool. What you see on the screen right now is basically a pretty classic ASP.NET framework web application, which has a bunch of web forms, It has an API controller. So, I mean, a common app pattern for framework web applications. And this web application, as expected, is using log4net for writing logs to local disk. It's also using a local SMTP server where it is, at least for the demo purposes, it is writing mails on a local disk. So you do see that there are a bunch of dependencies. And if I go back and further look inside the components, I can also show you that my database connection is actually stored in a registry key. So these are all the different dependencies that my application has. Now, I plan to move this application to Azure App Service. What I need to do is I'll right click my solution and click on Modernize. I'll say migrate to Azure, and I'll just wait for the assessment to complete. Once the assessment is complete, we'll actually see the assessment report, and it is actually going to provide us a bunch of different targets on Azure. So as you can see, for framework web applications, by default, the target is Azure App Service Managed Instance. And what you can see here is for things like logging, it will actually tell you that if you are targeting managed instance on Azure App Service, prefer App Insights or App Service logging, and if file system logs are required, write to a mounted Azure file share, and that is exactly what I'm going to demo a little bit further. If I further dwell into the assessment report, I can actually look at file system management, what to do with the static content. So we are pretty much covered in terms of how the GitHub Copilot App Mod tool works with updated rules targeting Azure App Service Managed Instance. And again, it pretty much helps you using the generative AI capabilities of GitHub Copilot to help you accelerate your deep code analysis and helping you choose your modernization target, or even migration target on Azure. And just to further explain what I'm saying, as you can see, for app service managed instance, the mandatory issues are 0 and potential is 4. But what if I go and change the target to Azure App Service Windows? You see the count changing. Now there are 2 mandatory changes. The reason behind this is that architecturally, App Service Windows, the way we know it, basically runs on a sandbox, and due to the security lockdown, there are a bunch of things that you are unable to do currently. For example, if you need to write to registry or read from registry, or you need to run an MSI installer, those sort of things you'll not be able to do in the app service windows that you have currently. But if I move back to Azure App Service Managed Instance, you can see those blockers are automatically resolved for you. And that's the reason why at Ignite last year, we launched the public preview of App Service Managed Instance so that we can make it much easier and faster for you to migrate your web application over to Azure. Now, how do I go about migrating this app? I mean, if the simplest way I can tell you is you can even go to your project, right click, publish to App Service Managed Instance, or as Andrew was mentioning, that I have actually written a blog with a pilot source code on how you can use agentic migration flow using the existing PowerShell script. So here is the blog where you can actually download all this source code from GitHub and play around with the agents that I've developed. You can modify them if you need to. Assume you have already prepared for the migration. The first step in your journey is going to be to create an app service plan for managed instance on app service. And how you do that is you click on create resource. So you land in the marketplace experience, and there you start by typing managed instance. Once you do that, you can see you are now presented with this option called as web app for managed instance. Click on create, and it will take you to this experience. So you start by providing us the subscription. You select the resource name in existing one, or you can even create your own. I'll select the existing resource group. I'll give it a name. I'll select a runtime. Now you can see that the list of runtime is slightly lesser over here. The only reason is that for managed instance, behind the scene, what we are allowing you is actually a child Hyper-V VM. And on these are the various runtimes which are installed by default, but that doesn't mean that you cannot install other runtimes if your application requires, let's say, another version or a major or a minor version of the .NET framework or Node or Java for that matter. You can actually do that, and I'm going to show you how to do it. I'll select 4.8. And as we speak, we continue to roll out managed instance on app service to lots of regions continuously. Currently, for the demo purpose, I'm going to select West Central US. Now, you can create a new plan, or again, you can select an existing plan. And as Andrew mentioned, remember currently managed instance on Azure App Service is only available on PV4 SKUs. So maybe I'll just select P1 V4. If you want zone redundancy, you can switch it on. Now, this is where the experience of creating an app service plan starts to change a little bit. So what you see on this screen is we are asking you for a storage account, a container, and a zip file. The idea here is assume the same application that I just showed you requires SQL Server reporting services to be installed, or requires a custom component to be installed for which you already have the MSI. So the idea here is you go ahead and create an installation script, name it as install.ps1, zip it and upload it to a storage account. Now, while you're zipping the install.ps1 file, you should also include all the installers or any other MSIs that you want to be installed on your underlying instance. Once you do that, you select the storage account over here, you give us a container name where this zip file is stored, and you give us a zip file name. And the reason why you see identity here is, as Andrew mentioned, that security is paramount for entire experience, how we have built managed instance on app service. So what we do here is we use this managed identity for securing communication between the app and the storage account. So using this managed identity, we go ahead and download the zip file onto the underlying instance. We unzip the file. We run all the steps given in the install script. Just to give you a quick peek into what an install script is, as part of this installation script, you can see that I'm installing custom fonts, and I'm also enabling an SMTP server role. So it is not just about you installing a font or maybe a licensed component or your own custom built component, but you can even modify what kind of Windows features are enabled. So it could be SMTP, it could be you could even install Windows services, or you can even install an MSMQ client if you have to. So pretty much you have the entire flexibility that you require for your applications to be moved and improved with managed instance on app service. Let me go back to the browser. So I'll select the storage account. I will now select the container name, and I'll give the name of the zip file. So name of my zip file is, and again, the name of the zip file can be anything. It's just that the installation script file has to be named as install.ps1. And then you go ahead and select the identity. Now, one important point to note here is In case your application doesn't have a dependency, you can completely ignore this step. It's not mandatory that you need to have an installation script. If you don't need it, don't include it. But this is optional yet super powerful. Now next, click deployment. Now what happens on this tab is essentially this is the same experience that most of us are used to. What's happening on this window, on this tab, is that we are creating an app end of the day. And if you have source code sitting in GitHub, you can basically configure that on this page, and we'll go ahead and pull the code and deploy it on the web app once it's created. The next step is configuring the networking. So depending on your need, you enable the public access. And now, another major difference here is that instead of you having to configure virtual network or every individual application, what we are now going to do is we are going to create an app service plan for managed instance, and then the entire plan is configured to be part of the virtual network. So that effectively means all the web applications created within the plan are part of the VNet. I'll go ahead and select a VNet. And then you need to enable VNet integration, and you need to select a subnet for your web applications. I will next click review. Once it is ready to be created, I'll click on create. Now what will happen behind the scene is we will go ahead and provision a instance size that you have chosen, and then we will go ahead and provision an app service plan. We will download the zip file, run on the installation script, and then if you have given us the source code repo link, we will go ahead and pull the code and deploy. So that's how simple it can be. So now in the interest of time, I've gone ahead and actually created a managed instance on app service plan, and this is how it is. So as you can see, evidently, this is very, very similar to what existing app service plan looks and feels like. So no major differences other than you see a new option called as configuration. So this is pretty much what I showed you that I was trying to configure. So here you have the storage account, you have the script container, you have the name of the zip file, which all your installers and your installation script. Now, my application requires different storage mounts. So I have 3 storage mounts mapped to K:, L:, and H:. Now, if I have to create a new storage mount, I can just give it a name, maybe storage 4. And this could either be mapped to an Azure file. If that's the case, you again select this name of your storage account. Once you do that, you now select the file share. And again, the entire connectivity between your application and the file share is secured using a secret. So your connection string is actually saved as a key vault secret. So you need to give us a key vault name. Where is the key vault? And then you go ahead and select the mapped secret. And then you give us the drive letter. So maybe I can call it J:. So what this means is that basically I'm going to map a J: as to the Azure file share, which is created with the name mount_fs. Now it could also be a UNC path, as Andrew mentioned, this could be a file server on Azure or within your own data center, as long as it is accessible to the virtual network that this application is tagged to. Or it could just be a local file share. Remember, local mounts are ephemeral in nature, meaning for any reason, if this instance gets restarted, any content which is on this local file share will get lost. So please do remember that. And again, when it comes to local file share, you just select the drive path And that's how simple it is for you to go ahead and create new mounts. Similarly, for registries, as I showed in the code, that my application depends on reading the database connection string from registry. If I have to create a new registry, you again give us a registry path, something like 𝗬𝗀𝗀𝗃 local machine software. And now you will again have to specify the name of the key vault where the actual registry value is stored as a key vault secret. So let me go ahead and select the key vault. And as you can see, this pulls the secrets. So that's my secret. Now the registry could be a string or a D word. So again, that's how easy we make for you to even create registry files for you. And now registry, I am demoing a registry as part of the code, but imagine a scenario where you are installing a component which needs to write a license file to local registry. So even that's possible now. I'll click on cancel. And yes, I think by now you all know that Managed Instance on App Service does support secure remote connectivity using Bastion. Now the checkbox over here allows you to enable or disable remote desktop for this specific app service plan. And to use Bastion to securely connect to the underlying instance, you click on instances. Now, I only have one instance, so you see one instance being listed here. Imagine if I have multiple instances, you'll see all of them over here. For any reason, if I need to restart this instance, you can click on restart and the instance will be restarted. To connect to a secure RDP, just click on connect, and there you go. So you can see I already have the regedit open, so I can go ahead and verify that yes, my registry is created. I can look at the event log. I can look at the MMC snap-in, so I can actually see that the SMTP role is successfully configured. I have access to the underlying IIS server. And for any reason, if I want to troubleshoot further, on 𝗬𝗀, you can see there's a folder called install scripts. And with the name of your script, we will create a log, a folder where you can actually see the log of the installation file. So yes, you can do all of that. And if you want to see the overall adapter log on the 𝗬:, you can actually find this adapter.log file. Now, one word of advice over here that while you can do RDP, but remember, if you make any change, any configuration change or any installation while you are in the RDP mode, those changes are not permanent. Meaning, for any reason, if this instance is restarted again, all your changes will be lost. So the right way is that you please include all your installers or configurations as part of an installation script, put it in a zip file along with any required MSIs, and then upload and follow the steps that I already demoed, so that across scale out, scale up, and restarts, all of those changes and configurations are persisted. I'm going to close this. So that's how the install zip looks like. It's just a storage account. I've uploaded a zip file. Now, as you can see here, that I have this app, which this is the app that we created within the plan. Now, again, there is no difference between an app on a managed instance plan when compared to a standard app service Windows plan. So that is the power, that's the beauty of this solution. So now if I really need to scale out or scale up, the experience is consistent, it remains same. I can now use deployment slots. I can configure deployment center. So imagine you have this application on-prem, and now you have migrated your application without making pretty much any change, or maybe just minor changes to your code. You are now on Azure App Service. You can use the power of quick deployments using slots. You can make quick changes to environment variables. You can configure authentication, use identity, or set up resiliency using backups. You'll get support for custom domain certificates, and you can even scale up and you can scale out based on rules, or you can do that manually. So that these are some of the benefits. Now, I'm going to take this a step further. I'll go back to Visual Studio for a moment. You remember, imagine this is my web application, and this web application has a REST API as part of it. Now, this is an inventory API, which has a bunch of methods which give me a detail of inventory, all inventory available or inventory available by ID or a certain category name. Now, as Andrew was mentioning, that one part of the entire move and improve or your modernization journey is moving your application over to cloud. The other bigger part is how do you make or turn these applications into intelligent app, or how do you enable these applications to participate as part of your agentic workflows? Because you really don't have to develop a new piece of code, or really don't have to write new functions every time. What if you have a super powerful, let's say, inventory management solution or a supply chain solution, which you would want to use as part of your agentic flow? So that's the idea that I'm trying to demo on the screen now. So imagine you have this REST API already with you. What you need to do now is generate an open API compliant JSON. So once you do that, these are the spec for your open API specifications. Once you do that, I'm going to show you something very, very interesting now. And I can actually create an MCP server against the REST endpoint that's deployed on App Service. And how you do that, come to the AI Blade. Remember, this is in preview, and this is a new feature that we are announcing at Build 2026. It's called Inbuilt MCP. So click on AI, and what you see here is give this a name. What should be the endpoint path for your MCP server? So I'll say Demo Build 2026. This is optional. This is where your spec.json file would be stored. Now, there are two ways to give us the open API specifications. I mean, you can actually browse and give us the file where it is stored. And then if you want to configure authentication for this MCP server, you can do that as well. Once you do that, as you can see here, it's very simple. So for the API that I showed you right here, if I go back to Visual Studio, you can see for each method or function within this REST API, we have created a tool call on the MCP server. And now how do I use it? Simple, just to test out, I can go back to GitHub Copilot. I can just ask a simple question like, and get me the invent. So now what GitHub Copilot is doing, it is basically talking to my MCP server and pulling in all the inventory using the tools that are available to it. And what have I done to enable this? I've simply, in the mcp.json file, I have included my MCP server over here. So that's the only change I have done. Now, I am just using Visual Studio, the GitHub Copilot inbuilt with Visual Studio to go ahead and talk to my MCP server. Imagine this could be your agents using this MCP server, or this could be any other coding assistant or tool of your choice. So that's how easy we are making it for you to go ahead and reuse your REST APIs as MCP servers. I'll take this a step forward, and as Andrew briefly mentioned, Imagine you require agents, observability. What you can do is, as long as you have your agents running on the app and you have the app insights configured, we'll give you this bunch of intelligence or this bunch of data about various agents. So you can see there are a total of 5 agents. In last 30 days, there have been 52 calls, and what's been the token usage in last 30 days, and what's the error rate. Now, if you need to dive deeper into every individual agent, you can actually click logs. This will take you to app insights. But again, that's how we are making it easier for you to deploy and observe your agents. And how you get here is the same experience where we had MCP server. Click on AI, MCP servers, and then you have the other tab called as agents. With this, I conclude my demo, and I'm again going to hand over back to Andrew to conclude the presentation and talk about next steps. Thank you so much for joining me today.
Thanks, Gaurav. That was a fantastic demo and great to see all those different things stitched together, all the different concepts that we have directly from managed instance, built-in MCP, and the GitHub Copilot app modernization tooling. And now I want to leave you today with a huge raft of resources and some final thoughts. So I'm going to leave you here with the App Service at Build 2026 blog. So you'll see there all of the announcements that we've made around Azure App Service today, all of the different capabilities that we've added to our platform that you can go away and read at your leisure and take an advantage of. Some notes there for Agentic app development with .NET. There's a series of articles there, three articles in a series that helps you walk through some Agentic app development and how to publish that and take advantage of Azure App Service. In the topic of embracing AI gradually, I want to introduce you into built-in MCP. So built-in MCP is the feature that we talked about earlier in the session and Gaurav demoed, where you can take an existing application with an exposed API and expose MCP tools. Another new capability that we announced at Build is the ability to observe your agents inside your app service app, something that Gaurav also shows inside his demo. Expect to see more developments on that as we see what you do and what your feedback is of these new capabilities. Finally, looking at lifting, extending, and modernizing your applications, or move and improve straight to PaaS, I want to leave you some resources there for managed instance on Azure App Service. So this takes you directly to our documentation and our overviews of how to get up to speed with managed instance and the power of the functionality that you've seen Gaurav demo. Information about the GitHub Copilot app modernization tooling, how you can exploit that and make use of that in a variety of different scenarios to modernize your applications, but also run assessments to identify anything that you still need to do as part of a modernization pathway. And finally, I'll leave you with a fantastic article that Gaurav wrote, where he's been looking at using an agentic IaaS migration pathway to managed instance. I encourage you to look at that and to see all of the power that you can build into using AI agents in order to speed up your migration journey. Thank you for spending time today with us to go through all of the capabilities that we've built into Azure App Service to enable you to accelerate your migration pathways and your modernization journey into the cloud. We're really excited to see what you do with our features and capabilities and see the real benefits of improved, accelerated migration to the cloud.